Hello and welcome. Today's presentation is brought to you by Science Visualized. And today we're looking at the reactions of aldehydes and ketones with nucleophile. So if you look at example number 1, we're starting with an aldehyde, reacting that with a nucleophile, and in this case we're using a negatively charged nucleophile. What's going to happen is that the nucleophile will add to that carbon, and then the double bond electrons will move to oxygen, and eventually that becomes an alcohol, and now you end up with a nucleophile added to that position. So you end up with an alcohol. Question number 2, we're starting with the same aldehyde, but now we are using alkyl magnesium chloride, which is a Grignard reagent, and in that case it generates a negatively charged nucleophile, so you end up adding that, and therefore you add those 3 carbons. You get that as the nucleophile added to that position, and the carbonyl turns to alcohol. Question number 3, we're looking at the same aldehyde, but now we're using lithium aluminum hydride, and that gives a hydrogen minus nucleophile, so you end up adding the nucleophile, which is hydrogen, and the carbonyl turns to alcohol. The last question there, we're using the same aldehyde, but now we are using alcohol, which is a neutral nucleophile. What you have to know is that with a neutral nucleophile, you lose the proton, and therefore you end up adding the alkoxide part or alkoxy part as a nucleophile. So you add that with the 3 carbons, and the carbonyl turns to alcohol. And this product is actually called hemiacetal. That means you can also proceed and replace the OH with another alkoxy, and that will give you a full acetal. Thank you very much. If you enjoyed this presentation, please subscribe to the channel and also like this video.